Okay,
Totally me. All right. How do we get the domain? Well, you remember, as I think we did in class. I asked you to shade all the points on the x-axis that correspond to points in the graph, right? And we kind of did this, well, let's just pick some points here. And project them down to the x-axis. So all these x values are in the domain, aren't they? And did we do this? I mean, is that familiar? Okay, so you kind of want to lock it in because in the homework, our graphs said, show the domain and range. You got this image and use this image, then you know what you're doing, okay? Makes it easy to do the problems. Okay, so, well, then it comes down to, well, we better do this one and we better do this one. Now, we don't have time to mark all the points there because they're infinitely many. So what we do is we find that yellow chalk. That's what colors I use before. And right there, the picture of our domain as it corresponds to this part of the function. Then this part of the function, well, the domain will go from here to here. We're going to extend the x-axis a little bit. Right there's our domain. Okay. Now, one other thing I can do is I can put an open circle up here and a closed circle up here that shows me that this is closed at this end. In other words, whatever the coordinates of this, whatever the x coordinate is here, this point is included in the domain. And then over here, put a circle, indicate that this point is not included in the domain, but every point up to it is. Then over here, we could do the same thing. Let's just be inclusive here. So we include both of these endpoints. So we have this. Stop it here. We project all these points over to the y. And all these y values are in the range. Then we realize, well, if we did it for all the points, we have all the points here, including this one, because this point is included, not including this one, because this point is not included. And then we can do the same thing here. Well, of course, this point is going to be included, but it's already in the range. We don't have to put it in the range twice. It's in the range, it's in the range. It's everything. We can do this. We can do all the points. You see now here. We get some new points in the range. Okay. So now we've got this point. And we've got all the points here to here. And we don't need this circle anymore because now this point has been included because it's over here. Okay. Because of the point here that projects horizontally to this point. So we don't need that closed circle anymore. And there it is. Okay. Now we pick a point on the graph. Actually, I'm just going to pick a point anywhere. Ready? Okay, there. That point is in the range. Okay. Sorry, that point might be in the range. I think it's low enough to be in the range, but maybe not. Anyhow, this point is going to be AZ. In my case, that would be 5 No. Okay, 5. Well. Okay. Now, if this point is 512, then I know that this on the x-axis is 5 here. And I come over to y-axis, and this is 12. Now, just coincidentally, that looks like it pretty much matches this. Okay? You might decide it's a little high, a little low. Well, you're gonna use your graph. And you're gonna pick your own point. I didn't say a point on the curve, although that's kind of what I intended. But, you know, you just stand back and throw a piece of chalk in your paper. You're probably gonna be more accurate than I was, but I was aiming for that quadrant, so I didn't do too bad. Had my eyes closed. Okay. But I had them open, I'd have probably missed the board completely. So then, according to the scale where this is 5, well, in my case, it looks like if this is 5, this is probably about 6. Okay. And this is probably about, oh, I could say 3.5, 6, whatever. Make sense? I can eyeball this. If this is 5, how big is that? Looks like about 2. Okay. And if this is 5, then -5 is probably about here. That'd be about -4. And if this is 12, yeah, I could say that's about 12. This is about 7. This is about negative. Okay. Once I know a point on the x-axis and a point on the y-axis, I can estimate. And all we're doing is ballpark range. If I think this is 3 and you think it's 4, that's all right. Okay. Now, if you think this is -6, we got a problem. And we'll fix it. Okay. And if you think it's 9, no, 9's out there, but you don't. Okay. Makes sense? Okay, now, if we do this with the domain and range, we see that the domain goes from here to here, then it goes from here to here. Now, on your scale, the numbers are going to be different. But if this is, let's see, we don't get it. 1, 2, we're going to say this is about. We'll do it like this. I'm going to say X is about 3.5. So this interval goes from about 3.5 up to 6. I'm going to put a dotted line here, X equals 6. I don't see anybody doing that. Okay. Important to do that vertical line and label it. Now, if you have too many of them, you don't have space to do them all, do at least some of them, so I know that you know what you're looking at. Okay. X is 3.5 everywhere in this vertical line. X is 6 everywhere on this vertical line. Okay. Almost looks like they're not equal. So this interval if X is 3.5 here and X is 6 here, then this is the interval. .56. 3.5 is included, so I use the bracket. 6 is included, so I use the bracket. Okay. Over here, I'm estimating that this line is X fractionally equal to 2. Yeah, use a reasonable estimate here. And on this line, X is approximately equal to what? Well, here's how big this is over here. I'm saying X is about -3. Might be a good estimate, it might not, but it's not ridiculous. As long as it isn't ridiculous, it's okay for now. Try to get better at estimating because it gives you a picture and it gives you a connection that you don't get from doing a bunch of symbols and algebra. And it makes sense of the symbols and algebra, which is really why we're doing it. That's all we want to do. Okay, well, then this is going to be the interval. -3, 2. I use a bracket here because we include -3. I use an open parenthesis here. Just a parenthesis because this is not included. All right. Then we can say that the domain is approximately -3 to union 3.56. That should be a bracket, not a parenthesis. Okay. And don't just write down this. Identify it. Identify it so you know what you're looking at and reinforce that that's the domain. Also, so when I look at it, I know that you mean the domain. So if you mess it up, then I know how to compare what you did with what you should have done. And hopefully don't screw me out. Also, if you happen to be reviewing for an exam and you need to review the exams come up. If you identify this as the domain, you're reviewing your work, then you know what that means. If you just write this down, you won't remember that. Okay. You come back 3 weeks later. You're not going to remember. Be nice to yourself. Identify what you're doing. You don't have to be nice to me. Okay. If I can't identify it and it's wrong, it's just wrong. There's no partial credit. So be nice to yourself and get that partial credit if there's some kind of, okay, by identifying everything you do. I'll give you the best credit I can based on what I see, but I'm not going to guess about what you mean. Okay. Now, if it's the right domain and I see everything else, then yeah, I'm going to give you credit for it. Okay. If it's wrong, but not too far wrong, I'm not going to guess whether you mean domain or not. Okay. If you tell me it's a domain, then I can kind of identify what you did wrong and maybe you get it. You get a point of partial credit or something. Okay. The range now. Well, this is 12. And this is 12. This isn't quite as big as 12. This looks like I'll say maybe y is about -9. So what's your range? Well, this is included. This isn't. The range goes from -9 up to 12. -9 is included. 12 isn't. So if you weren't getting these on your homework, I recommend you go to the half credit page and tell you how to do that. I'll tell you here in just a minute. You just log into the half credit page and work through the assignment again. Okay, so there's a half credit page that I've explained. You can go to a half credit page, leave any assignment for half credit. So if you're late, don't want to use late pass, you do that, then I'll give you half the credit. Okay, it's explained on the page if you get into it. Did you get into it? Okay, so I don't know if I wrote down all the right information because people weren't getting into it, but I've emailed it. Okay, well, yeah. This is the ID, that's the key. Okay. I didn't even see those arrows, but that's what they are. All right, go by the email. Well, that's it. And you can use it for practice. So if you did the assignment, usually got more than half the points. You're not going to get extra points by doing the assignment there, but if you didn't get it right, you go there and see if you're doing it right. Okay. Okay, so now let's go on to adding fractions. 5/11 plus 7/13. 5 times 13 over 11 times 13. And 7 times 11 over 13 times 11. Now, when I multiply by, essentially I multiply by 13 over 13. That's just like multiplying by 1. The fraction I get when I do this, which is 65 over 143, is totally equivalent to this one. It has exactly the same value, exactly same point on the number line, totally equivalent, but I put it in this form because when I do a similar thing to the other side, multiplying by 11 over 11, my denominators match up. So it's like I've got this thing, I've divided it into 143 pieces. Okay. And I've got this many pieces and this many pieces. Well, I just add how many pieces I've got here, which is 65, how many I've got here, which is 143. And I get 123. And that's how we add fractions. There's an assignment that I can throw in as an optional assignment if anybody wants it from the MDE 60. Or you could even go to the MDE 60 page, have credit page, and locate an assignment for adding fractions. It's much more extensive than the one I gave here because it's a skill I assume either you remember or just need a little refreshment. If you're having trouble with it, you need more than that, get to the mark, they can sit down with you and work on it. Also you have a more extensive assignment from the MDE 60 on adding fractions, okay? If you need it for practice. So whatever it takes, you have to know how to add fractions. There's no way when we get into chapter 3, later in chapter 3, that you understand what's going on if you don't understand this, okay? So get it out of the way now so it doesn't trip you up later. And you can do it. It's just not a big deal. You learn to do it in 5th grade. If you've forgotten it, it'll come back to you. Okay. Now we want to talk about inverse functions because that's an assignment that's coming up that some people already have in their assignment. So first, we have to talk about composite functions. I don't have time. Well, yeah, I'm going to do it. You've already done inverse functions. You've already done the inverse of the squaring function as part of homework. If you're in my Math 161 class, I'm sorry. That's what we do. Okay, so I'll just say very quickly. Okay, here's our. I'll do the e to the x. 2 to the x. I'm sorry. And what's your table look like? It looks like 1/4, 1/2, All right, not exact. It's not that it doesn't exist. 2 to the -1/2 does exist. We just don't know how to write it down completely as a decimal number. It just keeps going forever. You don't have that long to write it down. You calculate one digit at a time using some calculus, a Taylor series, okay? But you don't want to mess with that. And you can't, I mean, you don't have that many. Okay. Get a table for the inverse function. Which is y equals log base 2 of x. If that's important to you. Back here. In class, you know, you might need to know that. Okay, what did I do with the numbers here to get the numbers here? Okay. There's another picture that goes with this. Well, not labeling my graph, because everybody should at least, but I know what the graph looks like. Okay, if we switch the x and y components of this number, the x and y coordinates of this number, then, well, this is -2, right? And the x coordinate is 1/4. Well, if the y coordinate, which is 1/4, becomes the x coordinate, you can plot this point, you can verify that it's here. So this point corresponds to this one. Okay, this point corresponds to this one, which is here. And you can kind of visually see where it's going to be. Okay, 1, 0 corresponds to 0, 1, 1, 0 is here. Okay, 2, 1 will correspond to 1, 2. So it'll be here, and then you'll have this point, which is out here a little further. You get the same curve sort of flipped, okay? And you can see how it's flipped by drawing the line y equals x. That line goes through, for example, the point 2, 2. And the origin. And each of these points reflects across this line. If the graph is done accurately with equal x and y scales, each of these points will be as far on the other side of the line as this one was on this side. Just like a mirror reflection. And all these angles will be right angles. All these points, all these lines will go across the y equals x line at a right angle. Okay, 90-degree angle. There's a picture of how points reflect. You draw an accurate graph, equal scale on your x-axis and your y-axis. It's going to work out like this. Okay. Now, what I want to get to is if this is I'm going to do this quickly because I've a lot of time on other stuff. Let me get this across. Let me just think. I don't really want to use squaring function as the inverse restricted domain. Cubic function we haven't done that much with. reciprocal functions, its own inverse, that's what it is. Well, I'm gonna have to use a square function, okay. Okay, so let me just back off a little bit. Okay. Now, we've seen a little bit. If f of x equals x squared, then what's f of 2 equal? Well, now x is 2, so x squared would be 2 squared. F of 17, x is now 17, so f of 17 would be 17 squared. What's f of aardvark? Well, now x is aardvark, so x squared would be aardvark squared, obviously. Now, you don't know what the world aardvark squared means. Okay. You probably right now don't have a pet aardvark, so you wouldn't even be able to investigate this. Okay. And I don't think the whole the whole field of zoological science is going to help you figure out what an aardvark squared would be. Still, that's what the notation tells us, right? So what is, oh, let's say f of 12x. Well, x has been replaced by 12x, so we're going to have to replace x by 12x. It's going to be 12x squared. But this is around the whole thing. 144x squared if you write it out, but that's not what we're really after here. Okay. Okay, so what is then f of h? Well, if we have time, I'd like to see you write this down. Write it down for me. Not gonna have time to look at it. Just write it down quickly, commit yourself. And then you'll know whether you did it right or not. What would f of h be? Well, can't give you too much time here. H has replaced x, so h has to replace x. H is f of h is h squared. Okay. So what's f of u of x? Okay. I'm going to take a look. Let's see if you can write down what f of g of x would be. And don't worry about the fact that g of x is the square root of x. I wrote that over there. We're not worried about that at all. Just your literal. If you replace x with g of x, what do you get? Okay. What's x been replaced by? X has been replaced by g of x, right? So obviously then, if you replace x by g of x, you're going to get g of x squared. It's not g of x squared, although that kind of looks like maybe it ought to be, but it isn't. It's not what it looks like, it's what it is. Okay. What it is literally whatever's in here gets squared. And what's in here is g of x. So g of x is getting squared. Okay. Now, this is not g squared times x squared because it's not multiplication. This is function notation. G of x is the square root of x, right? Okay. So now we can do a little bit more with this. We could have done a little more with this. We'd have 12 squared times x squared and all that stuff. We didn't bother. Down here, it's not g squared x squared, because g of x is one lump. It's one notation. It means the square root of x. So this means the square root of x. Okay. Now, okay. So what do I mean by the square root of x squared? Simple examples. I asked, x is 25. What's the square root of x? People held up 5. You could have said it. I have the recording off. That's fine. Okay. Less noisy if you just hold up your hands. Okay. Okay. So if x is 25, the square root of x is 5. You square that, you get 5. That's 25, right? Okay. So we can write out. So the number we have here, same as the number we have here. Same here. Okay. Whatever number we put in. Well, the square root of x is defined as the number that you would square in order to get x. This has to equal x. So that g is an inverse function to f. So if you want to verify that a function is the inverse to another function, well, grid versus if and only if f of g of x equals x. Now, x is an input to the g function, right? So the g function outputs some value. It's now the input to f. Whatever you put into g gives you a number. And you put that into f and you get back to your original number. F undoes whatever g does. Now, there are two conditions. It's also got to be true that g of f of x equals x. Okay. So the number one thing, two things. Number one thing you've got to understand about composite functions is this. F of g of x, if f of x is a squaring function, f does to g of x whatever it does to x, okay? That's how you do composites. And here's what inverse functions look like this way, and here's what they look like in terms of composite functions, okay? And this comes full circle, like, okay, for this function, if x is -2, then y is 2 to the x, which is 1/4. You come down here, and you put 1/4 into this function, you get -2. Okay, you put 2 into this function, you get 4. You put 4 into this function, you get 2. You always get whatever you started with. You could even do it on the graph, but I don't want to confuse the issue. That's the bottom line. For inverse functions, they undo each other. And you gotta understand how to do the composites to test it. Okay?